This presentation will discuss a resource that I designed to aid student learning on the topic of transport systems in plants. I will lay out the context of the lesson, establish the pedagogical theories that underpin the justification for my choice of design, and critically evaluate how effective the resource was and how it could have been improved. The resource was a worksheet used for a Foundation Set Year 9 science class. This took place at an all-girls state comprehensive school. I had already taken 7 lessons with this class over the course of the term. They're a class of 26 and multiple students within the class had displayed a moderate amount of low-level disruption in previous lessons, so behavioural issues were a barrier to consider when designing learning tools for these students. I gauged that quite a high number of the students in the class displayed low confidence in academia, and at least 4 students had been highlighted as having low reading abilities. In previous lessons, the class had been learning the AQA content in the GCSE biology topic, organising animals and plants. They haven't officially started their GCSEs yet, but their scheme of learning does follow the content laid out for their GCSEs. I had, in my most recent lesson with them, introduced them to the structure and functions of different plant tissues. The lesson in which this particular resource was used was modelled on chapter 4.7. The learning objectives were for students to learn how xylem and phloem tissues differ, understand the purposes of substances transported in a plant, and learn how pests can damage a plant by feeding from the phloem. Potential barriers to learning I identified were as follows. The lesson relies on understanding terminology that was only introduced in the previous lesson, such as xylem and phloem, and words to be introduced in this lesson, such as translocation and aphids. Fully grasping the functions of the xylem and phloem relies on a sufficient prerequisite understanding of photosynthesis in order to make sense of why substances need to be transported in them. The lesson deals with fairly abstract concepts in the sense that they are invisible to the students. As defined by Alex Johnston, concepts here are on a submicroscopic scale with regards to the xylem and phloem, and on a biochemical scale with regards to the molecules being transported. There are also some potential misconceptions that students may have. They may believe that plants get water directly from the rain rather than from the soil, which could lead to further misconceptions of the xylem transporting water down rather than up, as would make sense due to gravity. Students may mistakenly think of the xylem and phloem as being subcellular structures, particularly as they may learn to associate them with lessons that commonly refer to plant organelles such as chloroplasts. Students may also believe that the reason aphids and similar pests kill plants is by eating most or all of the entire organism rather than reducing the sugar supply. Before we dissect the worksheet, let's establish 3 important pedagogical principles that influenced my decision to design the resource the way I did. Cognitive load theory is the principle that the working memory has a very limited capacity and learning will be inhibited if this capacity is exceeded in the process. If this happens, the learner experiences cognitive overload. Intrinsic cognitive load can be defined as the load exerted by the content to be learnt itself. Extraneous cognitive load refers to the load exerted from unnecessary convolutions surrounding the material. These can be thought of more simply as distractions. Both types of load are important to consider when designing any learning resource. Intrinsic cognitive overload can be avoided by ensuring that the teacher does not present a class with more information than students can feasibly expect to handle at any one time. Extraneous cognitive overload can be avoided by ensuring that any resources are not overly complicated in their format with regard to visual presentation or instructions required for their use. To implement cognitive load theory, as much as possible, students should keep students' mental energy focused on intrinsic load and should avoid activities that do not serve a clear purpose within the learning objectives. They should keep their resources free of visual clutter so that students' focus is more likely to stay on the elements that are important. This includes efficiency of wording as well as imagery. Teachers should also chunk the content so that students do not experience overload from being exposed to a higher amount of intrinsic load than their working memories will allow. It is therefore important to sequence the material in a simple to complex order in keeping with the rate at which the student can absorb information. Ideally, only a small amount of new information should be introduced at one time, and students should be given sufficient time to ensure understanding and application of the concept. According to Holmans and Yeomans, on average, your working memory can hold around 7 bits of information and only keeps them for about 20 seconds unless they are refreshed by rehearsal. Exact figures on this claim may vary, but the message is consistent. Students need to make use of the information they have received in order for it to stay. Simply rereading text is not effective. Students should retrieve what they have learnt. This will begin the process of transferring that knowledge from the working memory into the long-term memory, and will help the information to assemble into a schema, i.e. a set of established concepts that connect to form a single model in the mind of the learner. It is important that teachers actively check for understanding of a key concept before moving on. If there is a widespread lack of understanding across the class, the teacher should postpone moving on and revisit the concept with the class until sufficient understanding is assured. The vast majority of the literature recommends implementing regular low-stakes assessments in order for both the teacher and the student to check for understanding and regularly practice retrieval. There are a multitude of ways to do this, and they commonly involve quantitative marks. This does bring about benefits, but it can also demotivate low attainers, make high attainers complacent, and can cause students to focus on their score rather than addressing any knowledge gaps. At this stage of their learning, we are much more interested in ensuring that our current Year 9 students understand and can recite the concepts rather than focus on any scoring system. Here is an overview of the planned lesson structure. Note that the times presented show the estimated time into the lesson that each segment will begin and end, not the length of each activity. The lesson starts by linking today's objectives with concepts established last time. This has the benefits of re-establishing important baseline principles right from the start and also serves as an opportunity for some spaced retrieval. This is one of the most effective ways to transfer information into the long-term memory. It relies on a brief span of time for some forgetting to take place before the information is retrieved. The following 10 to 15 minutes consist of standard teacher talk to explain the key concepts. Admittedly, this duration probably stretched their attention as far as can feasibly be expected. I aimed to implement frequent questioning of the students in order to help hold their engagement. There was a highly visual PowerPoint accompanying the discussion in order to facilitate multisensory learning and dual coding, i.e. the theory that if both visual and phonological parts of the brain are engaged, the capacity of the working memory is greater. I rounded the discussion off by cold calling on various students to indicate general understanding across the class, a technique that has been heavily debated. Many publications advocate it as a useful incentive to keep students engaged, while others view it as an inducer of anxiety in the classroom. Personally, I found it to be quite an effective way of checking for understanding. The resource in question was then handed out to students after all key concepts in the lesson had been established. It is highlighted here in purple. For a focused student with no qualms on the topic, the sheet should only take a few minutes. So there was a follow-up task on exam-style questions that would take the rest of the lesson up until the point when it was time to go through all answers and write in any corrections. At this point, I used this time to cold call on students to check for understanding and have students mark and fill in any corrections with a green pen. The lesson ended with a quick plenary activity to summarise the day's lesson and once again check that students have taken on board the key messages. Here is the resource. I constructed it entirely from scratch. The point of the worksheet is to capture all important information that students should take from the lesson in just a few key questions. It can be thought of as serving three purposes. The first is to allow students to retrieve the information that has just been discussed and thus begin the process of cementing the concepts in the long-term memory. The second is to help the teacher confirm what concepts have been understood when the answers are discussed in class and any misconceptions that need addressing. This is ensured in two ways, partly by circulating when students are working, taking questions and addressing any signs of uncertainty or being off task, and also by cold calling when it is time to go through the answers. The third purpose is to act as a useful revision source for students once they have filled it in, as students can easily look back on it to retrieve the key points with minimal complications. The simplicity of the sheet is strategic. Everything about its design is about efficiency so as to eliminate as much extraneous cognitive load as possible. The lack of logos, the absence of imagery, the basic sentence structures, these ploys would bring benefits to any class, but particularly with a group such as this, where a number have demonstrated a relatively limited attention span and reading ability and are therefore easily deterred by sources that they might deem overwhelming. Even the font Comic Sans MS has been carefully selected as one that is deemed particularly reader-friendly. I also hole punched each sheet in advance so that students would not have to spend time doing this in the lesson in order to insert them into their books. Another design choice was the lack of quantitative marks displayed because, as discussed, I wanted students to focus on learning the concept rather than how many marks they got or what each answer is worth. There are some downsides to the resource being this plain that are worth considering. We have established that students learn most effectively from a multi-sensory approach. which this sheet, when in isolation, does not offer. Therefore, there would be a strong argument for including images of aspects that students are perhaps not used to visualizing, namely the xylem, phloem, and greenflies. The fact that I did not include images on the sheet meant it was important to compensate in other areas of the lesson. In this case, the slideshow presentation used in class discussion was very image heavy. One could argue that beyond a basic understanding of the facts, the sheet offers very little in the way of developing other skills that are sought after in the learning curriculum. For example, the ability to implement knowledge and demonstrate higher thinking, or the ability to comprehend more complex texts and pinpoint and utilize the key information. There is also a risk of the work being too easy for certain students, and research tells us that students will disengage if they are not challenged enough. My justification for both of these points is that students who find the sheet too easy should only need to spend a few minutes completing it before moving on to the more challenging task. The exam style questions that followed did stretch students' further thinking skills. This sheet serves as an ideal checkpoint to ensure the key information has been covered before students move on to greater challenges. Differentiating between the two types of task and sequencing them in this order is effective because research tells us that knowledge is arguably the biggest precursor to other forms of thinking. Therefore, schemes of learning that aim to push creative or critical thinking skills without first developing sufficient knowledge of the topic are commonly less effective than those that do take the time to build up foundational knowledge. Another consideration is that by itself, it's not a very thorough tool for checking true understanding, as students could easily get the answers from peers, or in some cases, they might write relevant answers without really understanding their meaning. The way to get around this is to ask appropriate follow-up questions in teacher-led discussions. It is also admittedly generic and therefore not a particularly exciting task for students. Whether or not this is an issue depends partially on how it relates to tasks in previous lessons. If students are receiving a broad range of activities across the curriculum, it is reasonable to predict that this sheet will engage them sufficiently. But if the nature of their activities is excessively repetitive, their enthusiasm and engagement is more likely to wane. The things that I deemed went well regarding the resource were as follows. All students completed the worksheet. Given that performance issues within the class had been common, this in itself is a noteworthy success. In fact, students ultimately produced more work in this lesson than they had done in most previous lessons when I had taught them. It is unlikely that this is primarily due to this particular resource, but it is a reassuring indicator that the sheet did not pose a significant obstacle. The questions selected to be on the sheet were effective for ensuring that students were absorbing the essential concepts and could mostly recite the key learning outcomes by the end of the lesson. This also meant that when I was circulating, if any individuals were unsure of any answers, I had the opportunity to go over the important concepts with them in a more intimate manner, and this should hopefully help to assure their knowledge more thoroughly. Once the answers were filled in, students could and were referring back to the resource with ease to help them with the next task and when answering questions for the remainder of the lesson and in future lessons. Finally, when we were going through the answers as a class, as well as talking through them, I revealed the answers by projecting them on the screen. This proved to be logistically convenient for both myself and the students. It meant there was no issues of students mishearing, no need for me to repeat myself, and no excuses for any students who didn't get the correct answers filled in. The areas in which I believe this resource could have been improved are as follows. It would have been preferable to put more scaffolding in place when students were completing the sheet. This would have come at the expense of lessening the retrieval effect on memory. However, the high frequency of questions I received from students during the task indicated that they were not ready to answer these questions purely from memory. If I were to repeat this task in future, I would leave an appropriate amount of relevant information displayed on the board. I would also shorten the time before discussing answers. There was no discussion interlude between the time that students were filling out the sheet and the time that students spent on the exam-style questions that followed. This was a mistake for two reasons. Firstly, it would have provided guidance so that any misconceptions would be addressed early on, and secondly, it would have provided more lesson structure and given students an incentive to get these questions finished within a tighter time frame. Another aspect I would change is more to do with the learning outcomes than the resource, but I would probably leave the content regarding pests for another lesson. The amount of content covered in the lesson would probably be fine for a higher performing class, but for this particular group, it might have caused an intrinsic cognitive overload. In hindsight, I believe these particular students would have benefited from more chunking by keeping the focus on the structure and functions of the xylem and phloem and saving the pest content for another lesson after being given the time to access the required concepts by spaced retrieval. Finally, I do now believe the resource would be improved by having one or two small relevant illustrations of xylem and phloem vessels to help cement the student's ability to visualize the concepts and implement dual coding. The accompanying slideshow was image heavy, but students won't necessarily recall the images when they look back at this resource. I would insert images with caution, however, probably only including them if they convey a clear point to students. In conclusion, my resource was made for a foundation set Year 9 science class studying transport systems in plants. The worksheet was designed for immediate retrieval, checking, understanding, and as a convenient revision tool. Design considerations included minimizing extraneous cognitive load by keeping it plain and to the point, and not having a quantified mark system so that students focus on addressing knowledge gaps. The ways I would improve it in the future include increasing scaffolding when I hand out the sheet, discussing answers more immediately after students finish, chunking more by saving some of the content for future lessons, and considering visual aids on the sheet itself.